Okay, so in this video, we're going to look at what we did with circles, but now with parabolas. So parabolas are the second type of conic sections that we're going to look at um, manipulating with in this section. So the standard form of an equation for a parabola looks one of two ways. It looks like x minus h squared equals 4p times y minus k, or it looks like y minus k squared equals 4p times x minus h. Now, the reason we have these two different types of equations is because you'll notice in the top type of equation, the x component is going to be squared, while the y component is not going to be squared. And it's the exact reverse in this second type of equation. Now, in both equations, there's going to be three main parts of interest. The first is the vertex. That's the point h comma k. And that vertex is going to be the sort of either the bottommost point, the topmost point, the leftmost point, or the rightmost point, depending on what way our parabola is pointing. Then we're going to have a focus. That's another point, which is p units from the vertex. And then we're going to have a directrix, which is also p units from the vertex. Now the focus is a point, the directrix is a line. It's going to be either horizontal or vertical, depending on what type of equation I have. So let me take a look at those just so that you understand what's going on. So the first thing I'm going to look at, and this is, by the way, looking at this on a Desmos calculator, desmos.com if you're looking for, um, is the difference between the two different types of equations. The one where we square our x component and the one we square our y component. You'll notice that when we square the x component, our parabola is pointing up, or technically, if you throw in a negative sign in there, the parabola would be pointing down. Okay, so it's either up or down if we square the x component. If you're squaring the y component, then the parabola is going to be pointing right, and I call this pointing right because the outside edges point right. Or if you put a negative in front, it flips and it points left. Now, obviously, at both of these parabolas, our vertex was at the origin of 0, 0. I made it that way to be kind of easier to look at. Now, let me just for a moment describe what the focus and the directrix are. All right, so what I've done is I've created the focus and the directrix on this equation. Now, if you go through, it turns out the focus, that p-value is 1/4 in this y equals x squared case. So the focus is a point that's 1/4. In this case, since the parabola is pointing up, it's 1/4 up from the vertex. So you take the vertex and you add 1/4 to the y value in this case. Obviously, if it was pointed left, right, down, you'd move that way in those cases. And the directrix is in this case, horizontal line that is y equals -1/4. So notice that for the focus, we went 1/4 up, and for the directrix, we went 1/4 down. Now, again, 1/4 is depending upon this equation here. It's the reason that we have this equation. Or I mean, it comes out of that equation and the standard form for the equation of a parabola. So that's where the focus and the directrix are. And these are special. This is a special point and a special line of interest because if you take any point on your parabola, let's say we take the point, this one here, which is the point 0.9, 0.81. So 0.9, 0.81. All right, that's the point. It turns out if you were to have looked at the distance from the focus to that point, and then you would have looked at the distance from this point all the way straight down to the directrix, those two distances would be equal. All right. Let's look at that algebraically real quick. So the focus is the point 0, 1/4, and I'm going to do this in decimals, so 0, 0.25. The directrix we said is the line y equals -1/4, -0.25. The point that I was talking about is 0.9, 0.81. And so if we look at the distance from the focus to the point, we take, again, change in x values squared minus change in y values squared. So change in x values squared plus change in y values squared, all under a square root. You calculate that out and get the square root of 1.1236, which comes out to a 1.06. So the distance between the focus and the point is 1.06. Now look at the distance between the directrix and the point. Well, like I said, the directrix you have to go straight down, so it's going to have the same x value in this case. So all we have to do to figure out the distance from the point to the directrix is take the y value, 0.81, and how far away is that from the y value of the directrix? So -0.25. And sure enough, you get 1.06. So the distance from the focus to the point is exactly the same as the distance from the point to the directrix. And that's going to happen no matter which point on here we pick. So no matter where we move this to, if you move this to, 0.5, 0.25, it's a pretty straightforward distance formula, 0.5 there, 0.5 there. So you'll see it's obviously a different number for each point we pick, but the thing I'm talking about is that it's always going to be distance from the point to the focus is the same from the point to the directrix. And that's how that always works. There's some really other unique things about parabolas as well. One is that if you take a line going vertically here and you bounce it off, so if you throw something, let's say, and it bounces off, it should hit the focus. So if it goes straight down, bounces off, you hit the focus. Goes straight down here, bounces off, hits the focus. And this is why satellite dishes are parametrically shaped, is that you try to take a signal, bounce it off, and hit a focus. Okay? So that's another little geometric thing that happens as well. Now we're not going to focus too much on the geometric aspects of this. What we're going to do is we're going to do the same types of problems as we dealt with before with the circle. So let's find the vertex, the focus, and the directrix, the three main components of the following parabola. Y squared plus x plus y equals 0. Now, the first thing we should notice is that this is not in our standard form like we had with the circle, right? So we're either in this one or we're in this one, but we are not in standard form. So the easiest way to deal with equations that are not in standard form is to put them into standard form. And once they get put into standard form, all the vertex, the focus, and the directrix will kind of all fall out of here. So we take this equation, and the first thing we do is we say, well, since this is a parabola, which component is the piece being squared? And we already know it's a parabola, so we're looking for the component which is being squared, and that's the y component. So we know that we're going to have a standard form that looks something like this. Y minus k squared equals 4p times x minus h. So what I would do is I would start out by putting all of the y stuff. Notice that when you expand this, you're going to get all the y components. When you expand this, you're going to get everything with an x component. So I'm going to subtract x from both sides and just be left with the y component on the left, and on the right, we're going to have, oops, subtract x. We're going to have the x components. Now, we should know how to do this, but this is going to hopefully be a reminder to you that when you square y minus k squared, we get y squared minus 2ky plus k squared. That's what you're going to get in the expanded version of a y minus k squared. So that's what we're going to try to create over here on the left-hand side of this equation. We're going to try to create a perfect square. And so what that's going to require us to have to do is to assume what k is going to be. Since the middle term is a minus 2k, and I have a 1 here, I'm going to have a k which is negative 1/2. Now, if we're dealing with a lot of negatives here, sometimes we just change these to positives and we can get it the way we want. So you can think of this as a plus 1/2. This is going to essentially, what this is telling us is that we need y plus a half squared on the left-hand side. Middle term, we go half of that. That's 1 divided by 2 is a half. And then we're going to have to add a certain term. In this case, we're going to have to add a 1/4 to the left-hand side to make sure that it's a perfect square. So y squared plus y plus 1/4 equals negative x, and then we'd always, since we added a fourth on the left, we have to add a fourth on the right. Hopefully that makes sense. If you don't know how to complete the square, obviously there's videos that you can look up that show you how to do that. So this perfect square on the left becomes equal to negative x plus 1/4. So now I have the left-hand side of the equation exactly how I want it. But the right-hand side doesn't quite look like this. So what I'm going to do is I'm going to factor out a 4. I'm going to, create, I don't need to factor out a 4. Let's do this. Instead of that, let's factor out something so that we have x minus h inside of parentheses. So we're going to let this 4p just stay as it is, and we're just going to go x minus h. So what do we have to factor? How do we factor the right-hand side in order to get an x minus h or an x plus h or something like that? So again, left-hand side stays the same. Right-hand side, if I want x plus or minus a number, well, what I'm going to have to do is I'm going to factor out a negative 1. If I factor out a negative 1, I get this as the standard form of a parabola. Now, again, here's my parabola. This is going to be an interesting look here. Y plus k squared equals 4p times x minus h. Now I have that form. Now I can just read off that the vertex has to be, well, it has to be x as a 1/4 value. Y is going to have to be a negative 1/2 value. Again, remember that's a y minus k. And, well, what's the value of P here? The interesting thing, 4P here has to be equal to -1. So if we're going 4P has to be equal to -1 in this case, what's that mean about P? P has to be -1/4. Oops, -1/4. All right. And we know that the focus has to be -1/4 units away from the vertex, and also the directrix has to be -1/4 away from the vertex, or I guess +1/4 away. So the question here is, now that we have this, which way do we move to hit the focus? Should we add 1/4 to the x value? Should we subtract 1/4 to the x value? Should we add 1/4 to the y value, subtract 1/4 to the y value to hit the focus? So what I like to do is think back to my parabolas with vertex centered at 0, 0. We have y equals x squared. That's pointing up, or if we add a negative in there, that's pointing down. Now our form has a y squared component equaling an x to the first component. So we have a y squared component equaling x to the 4. So we actually want this green look. All right, let me erase that. So we want the green look. And so it's going to either point right or left, depending on whether we have, positives in front of our x's or negatives. And it should be pretty clear to you, hopefully, that with this equation, highlighting this equation here, this is going to be similar to y squared equals -x. So we're getting the y squared equals -x version. So we're getting a parabola that's pointed to the left. And what that means is that when you're dealing with a focus, your focus should move to the left however many units that P is. And your directrix should move to the right however many units P is. So in this case, my focus should move to the left of the vertex. So we're going to take this vertex, moving to the left is a subtraction, in this case, of 1/4. All right. So we get a focus, which is the point 0, comma, -1/2. And the directrix will be a line. Now, be careful when you look at this. When you write a line, it is going to be a vertical line. So the equation of a vertical line always has x equals. We're going to take the x value of the vertex and add 1/4. So what we end up with is that the directrix is the line x equals 1/2. Hopefully that all makes sense. You can do this by hand from here if you'd like, but again, I like thinking through what we just did. All right, so here's what I'd like you to do. I'd like you to go to example 4 here, find the vertex, focus, and directrix of this parabola. So once again, you have to complete the square and then do that. Push pause on the video. I'm going to do this very quickly in the next few minutes or a few seconds. All right, so we got x squared minus 2x plus 8y plus 9 equals 0. That's obviously of the form where the x component has been squared and the y component is still linear. So what we do is we take and we want to put the x component on the left-hand side. So we get rid of the 8y and we get rid of the 9 on the left-hand side. That gives me an x squared minus 2x equals negative 8y minus 9. And these two steps we're kind of thinking through at the same time. Again, when you complete the square, what you're going to do is you're going to think, well, I need to create a perfect square on the left-hand side. This has given me my first and second term. I don't have my third term. So in order to complete a square on the left-hand side, you're going to have half of this number, this negative 2. You're going to go x minus 1. Again, half of negative 2 is minus 1. So x minus 1 squared is what we need on the left-hand side. That's going to require me adding a 1 to the left and then also adding a 1 to the right. So again, we're thinking about these two simultaneously. That x minus 1 squared is actually x squared minus 2x plus 1. So in order to get x squared minus 2x plus 1 on the left, I have to add 1 on both the left and on the right-hand side of the equations as well to make sure we keep our equation balanced. If we do that, we end up with this x minus 1 squared equals negative 8y minus 8. Factor out a negative 8, so you're left with x minus 1 squared equals negative 8 times y plus 1. Now that means that the vertex, since the vertex is hk, the vertex, therefore, has to be the point 1, negative 1. If you'll notice, p is negative 2, so p is negative 2 here. That means that the focus is negative 2 units away from the vertex. Now, in this case, you can check, but this parabola is going to go down. So we're going to, when I move the vertex to the focus, I am going to subtract 2. Again, p is negative 2. I'm going to do negative 2 from negative 1. So you get 1, negative 3 as your focus. And the directrix is going to be a horizontal line. So it's going to be a y equals. Again, that's because we're pointing down. You're going to get y equals 1. You're going to add 2 to the y value here. All right. So there you go. Here's the equation in standard form: vertex, focus, directrix. Now the opposite way, sort of the reverse, is finding the equation of the parabola with certain properties. So if I said there is a parabola out there whose vertex is 5, 4 and whose focus is 3, 4, how can I find the equation of that parabola? So the first thing we're going to do is we're going to think through what this means in terms of the direction the parabola is pointing. Is it pointing up, down, left, or right? So let's go to some graph paper here. What I've done on my graph paper is I've plotted the points 5, 4, and 3, 4. Okay, which again was my vertex and my focus. So I labeled those as well, 5, 4, and 3, 4. Now notice what's going to have to be true if I have a vertex here and a focus here. Well, what's going to have to happen, and hopefully you understand what's going on. My parabola is going to have to point this way. All right. So your parabola is going to have to point this way. It might be obviously wider than this or more narrow than that, depending on what's going on, but it's going to have to point this way. So that tells me what type of equation that I'm looking for. It also tells me that my P is going to be negative because we're moving towards the left. So I'll remember that the P has to be negative and that we have to be pointing this way. All right, so pointing left forces me to have this equation, y minus k squared equals 4p x minus h. And like I said, the p is going to be a negative because we're pointing towards the left. So this is a pretty straightforward thing. The vertex is obviously what we're doing with the HK. So 5, 4 is the vertex. So, whoops, I messed that up on the second one. So the K here is 4, and the H here is 5. So y minus 4 squared is equal to 4p times x minus 5. P was the distance between the vertex and the focus. That's going to be a -2 in this case because the focus is 2 units to the left of the vertex. So P is -2. If I plug in -2 for my P there, I end up with -8 as the coefficient of my x minus h, or my, in this case, x minus 5. So my final equation that I get is y minus 4 quantity squared equals -8 times x minus 5. Now you can graph that if you would like and see that you actually get the equation that you wanted to through the vertex, through the focus, and see what the actual parabola looks like too. Now I graph this is what I got here. Y minus 4 squared equals -8 times x minus 5. So I got the parabola that I've graphed in red. You can see it's a little bit wider than the one I graphed earlier. Um, I was just concerned about which direction it was pointing earlier. So there we go. It's a little bit wider, but we do have the right vertex. We do have the right focus. So what I'd like you to do is try another problem similar to that. Find the equation of the parabola with these properties. Directrix is x equals -2, and the focus is the point 3, 4. Push pause on the video and try that. Hopefully you did that. So the first thing I want to do is take a look at what's going on. The focus here is at 3, 4. The directrix is x equals -2. That is a vertical line over here to the left of the y-axis. So what you'll notice is a couple of things. In order to find the vertex is going to be halfway between the focus and the directrix. So the vertex is going to be right in here. Now I could calculate that if I wanted to. I'll do that on the other page. The other thing is because the directrix is on the left and the focus is on the right, that means that when I go to graph this parabola, we're going to be what I call pointed this parabola to the right. So it's going to be pointing to the right, again, because of the way the directrix and the focus are oriented towards each other. So the vertex is right here, halfway between the focus and the directrix, right, midpoint there. And then we're pointing to the right. So pointing to the right means that we're going to use this equation, the one where we're squaring the y and we have a linear component with the x. Since the directrix is x equals -2 and the focus is at 3, 4, we know that the vertex has to be halfway between there, which means, like I said earlier, that the halfway between the -2 and the 3, well, halfway between that, so what we will do is take 3 and add -2, whoops, and then divide by 2. That will be our x value. Our y value is just going to be 4. Hopefully you notice that. So our vertex is going to be the point 1/2, 4. Now what this means is that the p, remember p is the distance from the focus to the directrix, p is going to be a 2.5. And since we're pointing to the right, that is going to be a positive 2.5. All right, again, I'm looking at the distance from 3 to 1/2, and that's 2.5. You could have also found the distance from 1/2 to -2, and that's 2.5 as well. So we're going to use a positive 2.5 in as our value for P. And then since our vertex is 1/2 4, x minus 1/2 is going to be what we get when we replace the x minus h, and then y minus 4. All right. Now the only thing that I usually like to do here is I like to multiply out that 4 times p, and 4 times 2.5 gives me a 10. So what I usually like to do is write that out as a 10. And by the way, just like always, if you wanted to, you could use some graphing utility like Desmos or whatever you'd like, and graph that out if you want to. Let me go ahead and show you how to do that. So when I've graphed this out, I got this again, y minus 4 squared equals x over x minus 1/2. So I get this. You can see that the vertex is at 0.54 or 1/2 4. We're pointing to the right. Again, it's a little bit wider than I drew it, but you guys get the point. Now in the next video, we'll talk about doing the same thing with ellipses, and then following that, we'll deal with hyperbolas.